I like showing this image because there's John Pinder, my boss, looking very busy at a chart, which he rarely does, but there you go there. And that shows that we just look very closely at things. But could we believe the salesman? Because I just want to talk about, we purchased the 8125 particularly for REX, but also we were interested in wall surveys, and John was very keen for us to buy one of these systems. So do we believe the salesman? He said you could pick up 2 missing bricks in a wall. So John, as he did, practical approach, he was down in Plymouth at the time, I believe. He took 2 bricks, went down to the local Wicks or wherever it was, bought 2 bricks, put them onto a pallet, and he told us it was about 5 meters below the head, so maybe about a meter or so below the head, whatever it was. So yeah, if they weren't there, if the 2 bricks weren't there, we'd potentially hope we'd pick up that they weren't there. So that's the idea of, could we use this to pick up 2 missing bricks in a wall? The first key wall survey we did was in Dover in 2006. And they wanted to survey 7 kilometers of breakwater. They'd initially got 31 days dive time to do that, but we surveyed it in just 2 high water periods, so 8 hours. It took us about 3 months to process the data, but it was really good. And this is before we had POSPAC, I think so, maybe. But we're picking up that they were worried about loss of these large 1 meter granite blocks from the wall with the pressure of the waves on the outside of the breakwaters. And they were worried some were missing. We could pick up small erosion, and we also pick up construction. Potentially that wasn't erosion, it's just construction interface work that was here, lots of debris at the base. But we were able to tell them within a week or so that they had no missing blocks in the wall, so they were very happy. And this image was extracted from that, which I still think is a really powerful multi-beam image from back then. Again, a standard, talking about integrating processed or integrating different sort of data sets. That's just a standard photographic image. And we're picking up some very, this is a bracket that's about 100 mil across. Again, picking up some very good resolution on a tide station there. So we were getting very good results. And as for whether the salesman said it could be done, working with Net Survey in Canary Wharf, we surveyed 2 kilometers of dock wall. The contractor put his own diving engineer in to qualify our reported data, which we had 4 weeks to deliver before they did any diving. And then this shadow you see here ends up being 100 mil by 200 mil. So we managed to do it. We picked up the 2 missing bricks, verified by the client diver. So again, showing the potential if you get all the data right. Fine. And that's just another example of amalgamating different data sets, not integrated in acquisition yet, but is there again sort of a dock wall with photography, point cloud data of the tilted multi-beam, and then the dock bed DTM, which I have there as well. We've integrated into sub-bottom, so we can also take tunnel information in and put that into our scene file, etc. So since 2009, we've been tinkering around the edges of using vessel-based LiDAR. And we know that tilted multi-beam, whether it's electronic or physical, we've got electronic tilts now with the 7125 and the 8125H, which we didn't have before. So we designed all our mounts to be physically tilted. But there are benefits in coverage. Certainly we know it's sort of proven. The green areas are the areas you're sonifying. So if you're just in vertical mode and tilt mode running the same line, you cover a lot more in those shallow depths. So we keep the boat in the deeper water, at least we say we do, or we try to do, and we're covering all this area up here by having it in tilt. So really useful. One of the issues is, I don't know whether, I was a field surveyor for quite a few years, and that word, just one more line before we go home, used to be something that the crews were consistently annoyed with. And we've run 2 multi-beam heads into hard bottom and had to replace them with RESON, which is unfortunate. So we really did need to assess other methods because we've got a lot of intertidal area. So we've used airborne LiDAR. We've got airborne LiDAR that we've access to. It's very expensive. But we did some trials with Peter, Planix and Net Survey, etc. And this is an area outside our office of a muddy foreshore with some shingle behind, some sort of drainage channels here. And one of the issues people were worried about was the reflectivity. If it's wet material, it won't show very well with LiDAR. But we got really good data coverage across the whole thing and good definition. So in theory, it worked, and it did. Again, surveying 2 kilometers of area foreshore in central London. To survey that with a vessel, you're looking at maybe 3 or 4 high waters to get a full coverage. Difficulty with just access and lots of tight places in there. So again, we've sort of acquired this data, and it's working very well. So the second UCL project, which we're sort of nearly finishing up this year, we looked at potentially using LiDAR, again, sort of looking at the repeatability of this, so an absolute check. So Anna, one of the girls who did the MSc this year, we did an independent survey of our lowest bridge on the Thames, and we're looking at potentially using vessel-based LiDAR for acquiring all the span information on bridges. And so we put it on the Yantlet, the 2 systems, the Topcon and the Aplanix landmark. We can look at the higher resolution data, which we know it's a ILRIS high definition system that's on there. We get very good definition of the bridge structure, the point cloud, a little bit less with the Topcon. And then there was a full analysis of a very sort of solid control survey with land survey in there, and looking at differences with that and using Leica GeoOffice. And again, this is the whole span width with the landmark system. So really good consistency all the way out to the edge. It's a long-range system, so it would be. The Topcon system, more variable, and it would sort of deviate towards the edges of the span, which is 230 meters, we said. But again, we're looking at between 3 and 5 centimeter tie-in with the absolute check, which you consider there are still issues to be resolved with the calibration of that system. But again, very, very good results there. So we think we have identified the system we like. Okay. And really just running through some more eye candy here in the end, looking at these amalgamated data sets. This is an LNG jetty where we've acquired the multi-beam data for the submarine part, laser for the top, and the whole bed area. And looking for assessing verticality measurements for these piles. We said to them they should use a land surveying company, it'd be cheaper and more efficient, but actually to get onto an oil jetty, to be able to do it remotely, was of benefit to them with the health and safety regimes, etc. So that's an image, photographic image. There's the multi-beam here in the yellow, and there's the laser, so good. We've also done some work offshore. We sort of dipped our feet into the offshore area, not particularly out of choice, but with the customer who asked us to do that, and we've done some oil jetty sites, gas jetty sites with support from Aplanix at the time, and Net Survey again. Full laser imagery of the top sides and multi-beam of the seabed, the pipeline, etc., and the jacket itself. Have I time to do 2 or 3 minutes, John, to show the free viewer stuff?
1 minute.
Okay. Well, I'll show the one. So I'm going to show the LNG site. So it's quite a large data set, so it should open up okay. And just really look at the way we build that information with all the systems and integrating them. We've got the full pile structures of the jetty. We could even pick up the sacrificial anodes down here, which is really important. The contractor was meant to have put those further below the bed. We can take in the different parts of the structure, and we can also have some photography in there that we can superimpose into the imagery and have that for the client, which is all very useful. John's going to shut me down now, which is fine. And I just wanted to finish up in the last minute of looking at, we're talking about integrating photography into the system. So we've put this is a control survey of a jetty with the Topcon, because they didn't do that well at the bridge survey I showed. So we did some control, and they probably came in with about 4 to 7 centimeters on a jetty. And we looked at putting a georeference camera aboard, which is of great interest to the the asset managers of these. And there's an interesting sort of really quick, so trying to cover a laptop that's getting water in there. The guys are doing, just going around the jetty. And that information then, let's just finish there. Can I show this quickly, because it is of interest to us. This is that trajectory. So that boat that we saw there, the rib came out. This is a jetty down in Milford Haven, and this software has a free viewing capability as well. So we've got our photographic data in there, and this is a free view. And when you click on any of the points, you get your 360 photography that you can have in there. You've also got your down this here. You've also got the ability to have your all your photographs here. You can click on a point because the laser imagery is in behind, and you can click on a point and it should zoom into that point here. I think I've turned off one of the levels there, but it's of interest, and I think that's where we'd like to see the software developing for us. I think as Danny was saying, what he saw, the areas coming in, I think we'd like to see sort of cloud technology, the ability to improve free viewers and bring more data in there. Maybe we pay more for the software, but it's there for clients who aren't marine people. I think the message I had at the end relates back to the training as well, but technology is good, we know that, that's why we purchase the stuff we do, but you've got to have the right surveyors and people doing the job. Thank you. Sorry about the overrun, John.
It's wonderful to hear and see able to tell the truth.